Sorry. Establishing a trigonometric identity. Thanks, Quint. 1 plus cotan squared opposite theta is equal to cosecant squared theta. What rule are we going to use here? Anybody remember? Quint? It's from the even odd identities, right? Sometimes called the positive negative formulas. And we know that cotan of negative theta is what? Is negative cotan theta. So we get this one is this one, this plus sign is this one. But this negative sign, right? This is the rule we're using, isn't it, Quentin? That we know that cotan of negative theta is the same as opposite cotan theta, isn't it? So we're going to use this rule right here. We're just going to put it in here. We also know that cotan times cotan is cotan squared theta, right? So here's that square. This square is this one. These are equivalents, aren't they? But when you square a negative, you get a positive. So you get 1 plus cotan squared theta is equal to cosecant squared theta. And what is this? Yeah, good job. Exactly right. This is a Pythagorean identity. So this is a Pythag ID. So when your professor asks you, there's your proof. Deal? Let's do another one. Did this one bother anybody? This one, what I did when I looked at this one, Marion, is that I broke this down. I took all the, what are these called? Quotient identities. I use quotient identities here, often called tan identity. And so I just rewrote this, and I said cosine theta times, tan theta is, right, sine theta, isn't it, over cosine theta, plus cosine theta over, good job, sine theta. If you don't mind, I'm not going to rewrite this. I know that it comes along. Is that okay, Andy? Then I'm going to go ahead and multiply this out. Cosine times this is just sine theta, isn't it? Everybody see that? I'm distributing here and here. Cosine times cosine is cosine squared theta, isn't it? Over sine theta. But if you look at this really carefully, I'm going to go ahead and bring this thing down so I don't forget it. This gets really easy in just a second, but it looks bad for a second. I want to add these two quotients together, but I can't because we don't have a common denominator. So what I'm going to do is multiply this whole piece by 1 using sine theta over sine theta. Remember, this is over 1, isn't it? And then look what happens. Sine theta times sine theta, sine squared theta, plus cosine squared theta all over sine theta is equal to cosecant theta. Now what happens? Use a Pythagorean identity here, right? We know that sine theta plus cosine theta is equivalent to what? Look in your Pythagorean identities. It's 1. So this whole thing, right, Sarah, just replaces with this, doesn't it? So this thing replaces with 1. So sine squared theta plus cosine squared theta is 1. So that's this one. Over sine theta equals cosecant theta. Now what? This is a, good job. This is a, that's right, this is a reciprocal ID. Okay? Last one. Can you see how this is the same problem backwards? Right? That's why it was kind of good they put these things in this order like this. So I'm going to take this, I'm going to replace this with cosine theta over sine theta, quotient identity. Tan theta is sine theta over cosine theta, all times this sine theta right here. Remember, we're going to distribute to here and to here. And these cancel, these sine thetas cancel, don't they? Which just gives us cosine theta plus sine squared theta over cosine theta. We want to add these two together, don't we? But we don't have, good job, common denominators. So we're going to get common denominators by multiplying this by 1 using, nice, cosine theta over cosine theta. Right? And look, because this is 1, I don't have to distribute and multiply it by both things, right? I'm multiplying by 1. I can multiply any part of any equation by 1. It doesn't change anything, right? It gives us an equivalent back, doesn't it? Okay. Okay. So cosine theta times cosine theta is cosine squared theta. That's this times this, isn't it? Plus sine squared theta all over cosine theta is equal to secant squared theta because this is worth what? 1 over cosine theta is equal to that, isn't it? What's the identity you're going to claim here? Reciprocal identity again. Okay? Good work.